When we talk about traversing a tree, we mean visiting every single node in that tree. It's like taking a tour of the tree to see what's there. Why would we want to do this? Well, there are many reasons. Maybe we want to add up all the values in the tree, find the biggest one, or perform some other operations on data inside the tree. Now, here is the interesting part. When it comes to trees, we have options, right? You see, in linear data structures like arrays, stacks, queues, or linked lists, there's usually only one way to read the data from start to finish. But with a tree, things are a bit different. It's like exploring a maze with multiple paths. You can traverse or go through a tree in various ways, depending on what you want to do with the data. So, trees gives us the flexibility in how we explore and work with our data. Now, let's talk about how we can read the elements of the tree in the image above. Imagine you are reading a book from the top left corner and moving left to right. If we do that way with our tree, it would look like this. 1, 12, 5, 6 and last we have 9. Or imagine starting from the bottom left corner and moving left to right like this. 5, 6, 12, 9 and we can finish this with 1. But here is the thing. Even though these methods are quite straightforward, they don't really respect the structure of the tree, right? They only consider the depth of the nodes, only their position in the hierarchy. So instead, we use traversal methods that take into account the fundamental structure of a tree, which looks something like this. It's a structure named node representing a node in a tree. The structure has 3 members, an integer variable data to store the data of the node, and 2 pointers, left and right, pointing to the left and right child nodes respectively. Now, think of the struct node pointed to by left and right as not just individual nodes, but as whole subtrees with their own branches. Following this structure, every tree is basically a combination of 3 things. A node carrying some data, a left subtree, and a right subtree. Our main goal is here to visit every single node in the tree. So we need to visit all the nodes in the left subtree, then the root node, and finally all the nodes in the right subtree. Now, depending on the order in which we do this, there can be 3 types of traversal methods. Alright, let's dive into our first tree traversal method, which is called in-order traversal. Now, imagine you are in a dense forest and you want to explore it systematically. So here is how you do it with the use of in-order traversal method. First, you would explore all the trees to your left. Then, you would explore the tree right in front of you, the one you are currently in. Finally, you would move on to explore all the trees on your right. In the world of trees, especially binary trees, this method is pretty similar. It's called in-order traversal and it works like this. First, you visit all the nodes in the left subtree, then you move into the root node, and finally, you visit all the nodes in the right subtree. Now, let's talk about another method of exploring trees called pre-order traversal. Imagine you are on a camping trip and you come across a group of trees. Here's how you decide to explore them. First, you visit the tree right in front of you, the one you are currently at. Then, you move on to explore all the trees on your left. Finally, you explore all the trees on your right. In the world of trees, particularly binary trees, this method is known as pre-order traversal. It goes like this. You start by visiting the root node. Then you move on to visit all the nodes in the left subtree. And finally, you visit all the nodes in the right subtree. So, in a sense, it's like you are exploring the tree in a systematic way, beginning with the current node and then working on your way through the left and right subtrees. This method helps you get a good overview of the tree's structure. Let's explore another tree traversal method called post-order traversal. Imagine you are in a forest and you want to observe the trees in a particular way. First, you explore all the trees to your left. Then, you move on to explore all the trees to your right. Finally, you carefully note the tree you are currently standing at. In the language of trees, especially binary trees, this method is known as post-order traversal. Here is how it works. You start by visiting all the nodes in the left subtree. Then, you visit all the nodes in the right subtree. Finally, you pay attention to the root node. So, in this approach, you first delve deep into the left and right subtrees, and only when you have finished that exploration, you focus on the current node. This method helps you get a comprehensive view of the entire tree from the bottom up. Let's visualize in-order traversal. We start from the root node. We traverse the left subtree first. We also need to remember to visit the root node and the right subtree when the tree is done. Let's put all this in a stack so that we remember. Now, we traverse to the subtree pointed to the top of the stack. Again, we follow the same rule of in order. Left subtree, then root, and then right subtree. After traversing the left subtree, we are left with this. Since the node 5 doesn't have any subtrees, we print it directly. After that, we print its parent 12 and then the right child 6. Putting everything on a stack was helpful because now that the left subtree of the root node has been traversed, we can print it and go to the right subtree. After going through all the elements, we get the in-order traversal as this: 5, 12, 6, 1, and last we have 9. We don't have to create the stack ourselves because recursion maintains the correct order for us.